All right, we are at chain rule 2. We're going to get a little more practice with the chain rule. So I just want to remind you of what that rule is. If I want to derive, and again, it's going to look like f of g of x. Now, clearly, you can change those variables. I just want to go over that phrase again. We take the derivative of the outside, keep the inside, times the derivative of the inside. Okay, and keep saying it to yourself. So in this case, g of x is inside, f of x is outside, so derivative of the outside, keep the inside, times the derivative of the inside. And we just keep saying that phrase over and over. So we're going to run through a few examples, and these just have a lot of negative exponents, a lot of fractions. That's why I just split them up into two different sessions here. And our first step, of course, is to rewrite this for ourselves. So I'm going to rewrite this as h of x equals, the cubed root is going to turn into a power of 1/3. So just to remind you why this is not just the power rule can literally only be the letter x to a number, or one variable to a number. We have much more than just x raised to this number. So we say we have an inside function. So this is my inside and this is my outside. So if I want to derive this, again, I'm taking the derivative of the outside, which is a power. So think of it as the power rule. So I'm going to bring that power down, keep the inside, finish my power rule by subtracting 1, or in this case 3/3. I'm going to get a negative 2/3, times, and use parentheses, the derivative of the inside. So I'm just going to go through. The derivative of the inside would be 10x minus 6, just based off that power rule. And now we'll just work on cleaning this up. Because of that negative exponent, of course, and it's just on this term, this is telling me that's going to go to the denominator. So I know I'm going to have a fraction in my answer. So this 5x squared minus 6x plus 1. This 3 describes the root because it's on the bottom, so that is the cubed root, and I'm going to wrap that stuff up in there, raised to the second power. Now we'll just talk where these other pieces go. This 1/3, the 1 can stay on top, the 3 can go in the denominator. And because there's more than just 1, I don't really need to write it. I'm going to have the 10x minus 6. Now, 10 and 6 does have something that you could factor out at 2, but that's not going to reduce with anything, so I'm just going to leave that the way it is. And that would be our final answer to this chain rule. We'll try a similar one here. H of x equals 2 times the square root of that stuff. So again, I'm going to rewrite it, of course, because that would be step 1 always. 2 3x squared minus 5x minus 1, raised to the what power? Remember, a square root, square meaning 2, would be raised to the 1/2. Now, just want to stress that this is not product rule because this first term is just a coefficient. There is no x with it. So I am treating this as a chain rule because they have this huge inside function and this is on the outside. Remember, that's just a coefficient and it just comes along for the ride. So h prime of x, I'm going to start with my outside. The outside's going to come down. 1/2 times 2, of course, is just 1. Keep the inside. Finish that power rule. So I'm going to subtract 2/2. So I'm going to get a negative 1/2 times the derivative of the inside. So go to the inside and kind of derive each piece. 3x squared becomes 6x minus 5x, that's linear, so minus 5, and the constant is just 0. And lastly, I'm just going to clean that up. And so I'm going to say h prime of x equals, this bear again has that negative exponent, so it's going to the denominator as the square root of 3x squared minus 5x minus 1. And the rest of this can stay right on top. And we're good there. We don't need to rationalize these answers. They probably won't ever happen that way on a cleanup here. All right, looking at number 3. You notice there's 2 pieces separated by a minus sign. So again, my first goal is to rewrite. So when I look at this piece, I am not saying quotient rule because the top numerator does not have an x. So it's just a rewrite. So f of x equals, I have 4x minus, this is 3, And 2x minus 1, it's in a square root, so that's a 1/2, and I'm bringing it up, so a negative 1/2. So it's all about the rewrite. Now, you'll notice one of these pieces is chain rule and the other is not, and we can do them in simple steps because they are separated by this minus sign. Okay, so when I go to derive, the derivative of 4x itself is just 4. It's just linear, so its slope is 4. Now in the second piece, though, I do need the chain rule because I have an inside and an outside, and these are two separate terms. So I'm going to derive the outside by bringing it down. A negative times a negative is a positive. 3 over 1 times 1 over 2 becomes 3/2. Keep the inside and subtract 1, which again is 2 over 2. So I'm going to get raised to the negative 3/2 times the derivative of the inside. 2x is linear, so that's just a 2. 1 is a constant. It disappears. So I have to be careful how I write my answer because this is one term and then this is all one term. You can't cross things over on the plus side. We have to make sure we keep them separate. So this is still just 4 plus. So again, this piece has a negative exponent, so it's going to the denominator. So that's going to be, oops, I probably need a pen. The square root of 2x minus 1 to the third power. Remember, the root goes on the bottom. Now, I have 3/2 times 2, and that actually cleans up nice because these 2's just cancel, so I'm left with just a 3 on top. So my final answer is 4 plus 3 over that square root. Number 4, why didn't you, again, pause it, we'll do it in steps. Pause it, try to rewrite it, we'll check. Then pause it and try to take the derivative yourself, and we'll check. How did the rewrite go? The fourth root became to the 1/4, and you'll notice I missed my negative because I brought that up. So there's my rewrite, and then go ahead and take its derivative. So again, I can talk through my derivative if you need it. Take a look at it. Brought this down in front to get negative 5/4, kept the inside, subtracted 4/4 to get negative 5/4 times the derivative of the inside. So now as far as my cleanup goes, this has that negative exponent, so it's going to the denominator as the fourth root. 3x squared plus 7x minus 1 to the fifth power. Let's see, I have a negative 5 on top and a 4 on the bottom, and 6x plus 7 here. So this can stay on top, this can go to the bottom with my fraction, and this obviously will stay in the numerator as well. All right, so number 5, let's talk about the cleanup again. Because there's a 5 and a 3 here, I'm going to pull that out and make it easier for myself and just call that 5/3. Kind of ignore the rest of that stuff. And then I can bring this up as that 2x squared plus 4x minus pi raised to the negative 1/6. So again, I'm just calling that fraction 5/3, and it's this junk to the negative 1/6 power. So why don't you pause it, try the derivative, and again, we'll compare. But give it a pause and try it on your own. So take a look at it, see how it matches up. I brought my 1/6 down to get negative 5/18, kept the inside, minus 6 over 6 would be negative 7/6, times the derivative of the inside. So now I'll just work on that cleanup, of course. This becomes the 6th root of 2x squared plus 4x minus pi to the 7th. So I took care of that. I'm going to keep the negative 5 on top, the 18 on the bottom, and I'm going to leave that 4x plus 4 on top. Now, I could factor something out and clean this up a little bit or distribute this through because I see these 4's are both even, so I know something will clean up. So I have negative 20x minus 20 over 18 in that 6th root. And obviously I could pull out a 2 here and divide this fraction out as well and just simplify. Not that I need to at the moment, but you could do that. Similar to our other problems, write the equation of the tangent line and the normal line. So again, as soon as I see line, I'm thinking I need a point and a slope. So point, again, I'm just plugging in my 5 to get that point. So I'm looking for f of 5. And when I see slope, I want f prime to get that slope of 5. So again, I'm going to rewrite f of x with you to make sure we're on the same page. F of x is really x squared minus 9 to the 1/2. And I feel like we've done enough of these that you should be able to do this on your own. So pause it. I'll kind of have mine all written out. Try it on your own and then turn it back on and compare. All right, so take a look at my work. When I plugged in the 5, I ended up with 4 for my point. We had rewritten this together, so I took that derivative 1/2, left the inside to the negative 1/2 times the derivative of the inside. My 1/2 and 2 canceled. So I rewrote it like this, and then I plugged in my 5 to get 5/4. So I simply put my tangent and then my normal line together. Lastly, we want to find, again, f prime of 5 given this information here, and we just have 2 simple ones to look at. So let's go ahead and simplify with a rewrite here, of course. F of x equals g of x, all raised to the, when I already use parentheses, sometimes I like brackets instead, whatever works for you, raised to the 1/2. So I'm going to go ahead and take that derivative, so I have my inside and my outside. F prime of x equals 1/2 times g of x raised to the negative 1/2 times the derivative of the inside, g prime of x. So again, I just want to stress before I plug a number in, I clean up, clean up, clean up. So I'm going to say f prime of x is equal to, especially with negative exponents, that goes to the denominator as the square root of g of x. G prime stays on top, and my 1/2 gets written in there as well. And then I can find f prime of 5. So I really want g prime of 5 all over 2 times the square root of g of 5. G prime of 5 looks like 6, and the square root of g of 5 is the square root of 9, which becomes a 3, which I think gets me 6 over 6, which is 1. Okay. Lastly, let's rewrite part B here. F of x equals, this is going to become h of x all raised to the negative 1/2. So pause it, try your derivative, and we'll compare again. See what you think about that. I brought my negative 1/2 down, and I left my inside to the negative 3/2 times the derivative of the inside. So my negative 1/2, I split the negative 1 on top, technically the 2 on the bottom, brought my square root of that h of x cubed downstairs times the h prime of x. And I'll just carefully replace my 5's in there. So I have negative h prime of 5 would be negative 4. So I believe that then turns into a positive 4. And I have 2 times h of 5, which is 5, the square root of 5 cubed, h of 5. So I don't know the square root of 5. 5 cubed is 125. The square root of 125. This 4 and 2 reduce, so I have 2 over the square root of 125. And I think that does it. So like I said, we'll get a little more practice, and we look forward to any questions.